All right, welcome back from spring break. We're getting ready for the end run here. We've got 5 weeks and 2 days left, 27 school days left. We got 5 full weeks. Then that last week, I don't know if you've looked at the calendar, we go to school Monday and Wednesday. Right now, we're still scheduled to go back at the 1st of May, where that would make us do 12 days face-to-face, which I think most people are hoping happens. I still don't know if it's going to work out, but we'll see. All right, the subject today is probability. All right, I'm not going to lie to you. I love this stuff. This stuff is the stuff that is straight out of Las Vegas. Okay, compound probabilities is used for stuff like counting cards and stuff like that. I wouldn't suggest that all of you book your trip to Las Vegas to make your fortune out of this, but this does give you some of the principles of likelihood of events happening. The way that probability works, and we're going to be dealing with just marbles in a can. All right. Each can is going to have a certain amount of, and I think all of our problems in Delta Math are 3 colors. You've got red, blue, and green marbles in a can. All right. Compound probability means what's the probability of 2 things happening. So I'm just going to jump straight into the problems. All right, you can see I've got a can here, and in this can I've got 3 red marbles, I've got 3 blue marbles, and I've got 3 that's supposed to be green. Three green marbles. All right, so it's a total of 9 marbles. I want to know what's the probability of me reaching into that can and at random, I can't see what's in the can, at random pulling out, in 2 picks, pulling out 2 red marbles. All right, here's the way you calculate that. First thing we want to do is first think about what's in the can. There's 3, 3, and 3. There's going to be 9. All right, there's 9 things I can pull out of that can. All right, the probability with this first marble, the first one I reach in and get, of it being a red marble is going to be, there's 3 of them in there, so it's going to be 3 chances out of 9. Does that make sense? Reaching that can, there's 3 chances out of 9 that I can pull out a red marble. All right? But this is a compound probability. What's the chances if I can reach in there and pull out a red marble, then on my second pick out another red marble? And this is pretty easy as far as just figuring this is just multiplication. I'm going to multiply the 2 probabilities. All right. First time I reached in, I got a red marble out. All right. Now I want to see what the probability of me pulling out another red marble out. Well, here's the part you've got to remember, and this is the kind of, I'm not going to say tricky, but this is the memory thing you have to remember. There's only 8 marbles left in there now. All right, there's only 8 marbles left in there, and the chances of me pulling out another red one is just going to be 2 out of 8. It's not 3 out of 8 because I already pulled one of the 3 red marbles out. All right, so my first pull, okay, the odds of me pulling out a red marble were 3 out of 9. The odds on me to pulling out, odds or probability, you'll hear me say both, of pulling out a red marble on the second one is 2 out of 8. The probability of me doing both of those, you just multiply straight across. That's going to be 6 out of 72. All right. Each one of these problems I do, I'm going to give you 3 ways of entering the answer, because Delta Math asks you in 3 different ways. If it asks you the exact way, you just type this in like this. If it asks you for exact, you type in 6 over 72. Fractions are always exact. All right? If it asks you for tenths of a percent, okay, percent's the key, okay, you put this in your calculator. 6 divided by 72 is going to give you this. It's going to give you 0.08333. Right? It wants to know tenths of a percent. All right, to get tenths of a percent, remember percent is going to be a percent sign. So we're going to multiply this by 100 times 100. All right, you multiply this by 100, you're going to get 8.3333. All right, this says to the tenths of a percent, so this is going to be 8.3%. Okay, this is exact. This is the way to do it if it says tenths of a percent. And the last way it's going to ask is to the thousandths place. That one, it's not thousandths of a percent, it's thousandths place. Okay, it's not percentage, it's just a decimal. So to do that to the thousandths, okay, you're going to just cut it off here. So to the thousandths, it's going to be 0.83. Right? That's to, it'll say to the thousandths. That's not spelled right. And I think it says it like this anyhow, to the 1000s. Okay? So three different ways. This one up here is exact, this one here. Okay? This one where you multiply it times 100, then you cut it off to the tenths place. This is the percentage. It says to the tenths of a percent. And this final way is to the thousandths, not the thousandths of a percentage, just the thousandths. I'm going to do enough problems here where you'll see, and in each one of these, I'm going to do all three ways. But when you do these on Delta Math, it's going to ask you, do it exact, do it to the tenths of a percent, or do it to the thousandths. All right. Okay, I'm going to figure this all three ways. But like I said, Delta Math is only going to ask for one of the three ways. The beginning part of this, you do the same for all three problems. All the problems. Okay, this wants to know the probability of drawing 3 green. All right. So, inside my can, if you add these up, there's 17 marbles. Okay, so I know it's going to be something over 17. All right. So the probability of me reaching in here and drawing out a green marble on my first marble is going to be 7 out of 17. There's 17 green ones. There's 7 green ones and 17 marbles. So the chances of me drawing out a green one is going to be 7 over 17. All right, I've drawn out a green marble. I'm going to reach in again. What's the probability of me drawing another green marble? Well, I've already taken one out, so there's only 16 left in the can. I've already pulled a green marble out, so there's only 6 left. So the probability of me drawing a green marble out on the second one is going to be 6 out of 16. All right. If you look up in my description up here, it says, what's the probability of 3 green? All right. Same thing. I'm hoping you're starting to see this. There's only 15 marbles left in the can, and there's only 5 left now that are green. So the probability of me drawing out a green marble on my third pick is going to be 5 over 15. All right. Now I'm going to do, everything I've done so far is the same for all 3 ways of answering. Okay. First, I'm going to do the exact. If it says, what's the exact value? Okay. You multiply straight across. 7 times 6 times 5 is going to give you 210. And then you multiply 17 times 16 times 15. You'll get 4,080. Okay. That is your answer for exact. Okay. I'll put that there. Exact. All right. The next way, it's going to say 1/10 of a percent. All right. 1/10 of a percent. First thing you're going to do is put this in a calculator. 210 divided by 480 or 4,080. You're going to get a number that looks like this. 0.05147. All right. I'll put this line here. All right. You multiply that by 100. It's going to give you 5.147. Okay, but it wants to know the tenths of a percent, and this is percent now. You multiply it by 100, so it's a percent. So by the tenths of a percent, the answer is going to be 5.1%. Okay. Right, the final way. You put the same number in the calculator. 210 divided by 480, you get the same number here. I'm going to write it down here though. 0.05147. And the third way it asks you is to the thousandths. To the thousandths, all right, all you do is cut it off here. 3 numbers past the decimal. This 4 doesn't round up, so your answer for this is just going to be 0.051. So, same math, it just asks you for 3 different ways. One of the things I haven't mentioned is the Delta Math problem generator will give these to you in words, but it's easy for you just to draw you a can like I'm drawing, and just I would suggest you do it like this. It keeps you from making mistakes. Inside this can here, I've got 5 red, 4 blue, and 7 green, and it wants to know what's the probability of me of making 3 draws inside there, and each one of them being green. All right. So let's go to the first one first. First, we need to add all these up. The chances of me reaching in there and drawing out a green one is going to be, there's 7 green marbles, so it's going to be 7 out of 5 plus 4 is 9 plus 7 is 16. So there's 16 marbles in there. The probability of me drawing out a green one is going to be 7 out of 16. All right, I've drawn out a green one. What's the probability of the next one being green? There's only 15 left in the can now because I took one out, and there's only 6 green ones left. So my odds of drawing out a green one is 6 over 15. And hope you see by now, the next probability of drawing out a green one on the third draw is going to be 5. There's 5 green ones left over 14, I'm sorry. All right, now we multiply straight across. If we do that, we get 210 over 3,360. So this is the easiest problem to do. If it asks you for the exact, you type this in. You type 210 divided by 360, or over 360, or 3,360. Type it in just like that. That's your exact answer. It'll be right. All right, the next way is it's going to say to the tenths of a percent. Okay, first thing I got to do is turn this into a percent. All right, I put this in a calculator. I'm going to come up with 0.063. All right. And if I multiply that by 100, I end up with 6.3, and that's what I want, 6.3%. I don't think you have to type the percent in, but I'm going to give you extra tries at this, so don't fret oh God, is this going to be right? You're going to have some opportunity to make mistakes because of the rounding and stuff. So this is to the tenths of a percent, and the other one's to the thousandths. Just a decimal, not a percentage. So if you notice, this 0.063, it's 123. It's already there. That's your answer. If it asks for the thousandths, it's 0.063. So exact, to the tenths of a percentage, and to the thousandths place. That's the 3 different ways. Just 3 different ways of looking at this. All right, this is my final one I'm going to do. All right. Guys, I ask, you can tell because I assign points to it. I want you to watch my video. But if you go through it and it didn't help you much, try their video. I mean, I don't watch all their videos, but it might be better. I mean, it's not going to hurt my feelings if you try the other video. All right, so this is the probability of drawing 3 red, right? So again, first thing I want to do is add it up. There's 15 marbles in this can. 8 plus 4 is 12, plus 3 is 15. So 8 plus 4 plus 3 is 15. So I know it's going to be something over 15. And the probability of drawing a red out is going to be 4 out of 15 on my first draw. Right? Then on my second draw, that means I've already got a red out. So I'm only going to have 3 reds left, and I'm only going to have 14 marbles. Probability of drawing the next, because this is compound probability, okay, there's only going to be 2 red ones left, and there's 13 marbles. All right, I just have to multiply that straight across. 4 times 3 is 12, times 2 is 24, and 15 times 14 times 13, I got to get out my calculator, and it's 2730. Whoops. 2730. So for my exact answer, I would just type in 24 over 2730. All right. For my tenths of a percentage, okay, tenths of a percentage, looking at the percentage, I'm going to put that straight in my calculator. If I put that in my calculator, I'm going to come up with 0.008791. Multiply that by 100, all right? I end up with 0.8791. All right, I want to know to the tenths of a percentage. This isn't even a full percentage. This is, it's 0.8791. It wants to know to the tenths of a percentage. It's not even a full percentage. If it was a full percentage, this would have been a 1 something. So this wants to know to the tenth, so I'm going to cut it off right here. Right? So that's going to be 0.9%. Very small. Right? If I want to know this to the thousandths, all right, the answer is going to be, I'm going to go over use the same number again. I don't have to enter this again. 0.008791. All right, to the thousandths is going to be right here. So I'm going to round that. 7 rounds up. The answer for this, if it's to the thousandths, is going to be 0.009. All right. So I'd suggest if you're struggling with this, and I think everybody's going to be good up to here. That's pretty cut and dry. I think the difference between percentage percentage into the tenths and the thousandths is going to be a little bit confusing. I'm going to put this down to each one of these problems I assign. You get 3 tries at it. Okay? If you get it wrong, hit the example button. It'll give you a problem just like it. So you get 3 tries at every problem. So rounding, don't fret it. Don't get too wound up in it. Just take your time with it and write down some notes. Put stuff on your paper. Don't try to keep the stuff in your head. Take shortcuts just to get this done. This won't take you that long, especially if you write it down. All right, guys, you have a good day, and I will be posting something about midweek.